There are many types of solving two-step equations, as you can see listed here on this page. I will be solving all of these in this lesson, starting with what I think is the most common, being the simple, to the more difficult and much more uncommon. Since the word solve means to isolate the variable using inverse operations, we need to undo all of the operations that are happening to the variable. In this problem, 4 is being multiplied to the variable, and 23 is being added to that term. When we undo these operations using inverse operations, that means we will need to divide by 4 and subtract 23. The question becomes, which order do we do those in? According to the order of operations, when we simplify an expression, the multiply happens first. Then the addition would happen. When we solve the equation, though, we want to work backwards on the order of operations and undo the add first. So let's subtract 23 from both sides, which gives us 4x equals 60. And then we do the divide by 4 to both sides, and that gives us x equals 15. This is said to be our solution for the equation, and that can be checked by substituting, that can be checked in the original equation by substituting that value in place of x, which I will do with parentheses. And since I am checking, I'm going to put a little question mark above my equal sign to make sure that anybody looking at my work knows that I'm checking my work. Following the order of operations now, simplifying the expression on the left side, I get 23 plus 60 after multiplying, and that is equal to 83, or I'm checking to see if it really is. And now when I simplify the left side with addition, I get 83 equals 83, and I have checked my solution. This problem needs to be simplified using the distributive property before we can start doing solve steps. So technically there is a step before the two steps. This doesn't count as a solve step though, so it's still a two-step solve equation. If we use the distributive property, 9 times 2n becomes 18n, and 9 times negative 8 becomes negative 72, and that's equal to 60. And now I follow my procedure from the simple problem from before. Adding first to undo the add-subtract step. This leaves 18n equals 132. Now I divide both sides by 18, reduce the 18s, I'm left with n is equal to, this fraction simplifies to 22/3, which could also be expressed as 7 1/3 in mixed number form. On the right side here, instead of checking my work, I'm going to demonstrate that we could have done the division first instead of distributing. I could divide both sides by 9, reducing the 9 out, leaving only 2n minus 8 on the left side of the equation. The right side of the equation simplifies to 20/3, which most people don't like to deal with fractions throughout most of the problem. And this gives us a pretty good reason why we should not do division first. We should undo the addition or subtraction step first. Anyways, now I have to deal with this fraction throughout the rest of the problem. So when I add 8 to both sides, I need to add 24/3 to this side, which is the equivalent of 8, but I have changed that so that I'm adding things with like denominators. Here my 8's are gone. I've got 2n equals, now I've got 44/3. And when I divide both sides by 2, that's the same as multiplying by 1/2. Remember that dividing by a number is the same as multiplying by its reciprocal. Here the 2's reduce, and I get n on that side. Over here, the 2 and the 44 are going to partially reduce, Since 44 is really 2 times 22, the 2 will reduce with the 2, leaving me with 22 thirds, just like my other answer. In this problem, notice that the variable is in the numerator, which counts as being part of a group. Groups being the first thing in the order of operations means that when I solve, it's the last thing to be undone. So in this problem, I'm actually going to be multiplying by -3 before I undo the addition step. This -3 reduces with that -3, leaving m plus 6 on this side, and the right side becomes -12. Now I undo the addition with subtraction, which again seems backwards, but it was all because the variable was in the group in the numerator. Commonly we see fractions in our problem that we don't want to have to deal with. Finding the LCD, which is the least common denominator in this problem, is 6. I'm going to multiply every term by 6, which will be partially reducing with each of those fractions. 6, remember, is 2 times 3, so I'm going to distribute a 6 throughout the entire problem, giving me partial reduction, again, on all of these. After reducing the 3 in the first term, there would be a 2 left over, and 2 times the 2z gives 4z. After a partial reduction with a 2 in the second term, there would be a 3 left over, and 3 times -3 becomes -9. After a partial reduction of the 6 with the 2 in the third term, there's a 3 left over, so 3 times 3z becomes 9z. And after a partial reduction with the last term, I would have a 2 left over, and 2 times -17 is -34. Now I've got variables and constants on both sides of the equation. My strategy is to eliminate the smaller variable term first. So I'll subtract 4z from both sides, and that will eliminate a variable term on the left. Since I'm eliminating the variable term on the left, I'm eventually going to want to eliminate the constant that's on the right. I can actually do that as part of the same step. And that eliminates the constant from the right side. So now the left side has my constant, which is 25, and my variable term on the right is 5z. This only requires one more step, and it reduces to 5 equals z, which I'm going to express as z equals 5. In this problem, notice that the coefficient of the variable term is a fraction, and instead of dividing by a fraction, I'm going to multiply by a reciprocal. A common mistake here would be to only multiply that term by the reciprocal, but I need to multiply every term by 4/3. This problem would have actually been easier, and let me back up and do that, because I'm supposed to undo the addition first. So let's subtract 2 from both sides, giving me 2 2/3, which I'm going to call 8/3. It'll be easier to work with this if it's in improper fraction. So 3/4 x is equal to 8/3. Now I multiply by the reciprocal. The 4 reduces with the 4, the 3 reduces with the 3, giving me the coefficient of 1, which is what I want. And over here I need to multiply the 8 times 4 and get 32 as the numerator, and 9 as the denominator. This problem is not much different from some of the others, except for the fact that I've got a negative coefficient. In this problem, that's not going to make much of a difference. So t is being divided by -5. I'll multiply both sides by -5. And that gives me -150 equals t. Notice that the negative multiplied or divided with the other negative to make a positive t, and the 5 reduced with the 5 to make a positive 1. So I achieved both clearing the sign and the numbers by multiplying by -5 all in one step. In this problem I need to distribute and then get my like terms on the same side before I can actually do the 2 steps. So 12s equals 8. Distributing the 2 gives me plus 10s plus 6. I've got variable terms on both sides. I'm going to get rid of the smaller one. That's going to give me 2s equals, and right now I'm actually going to combine my constants on the right to make 14. Now I've only got one step left, and s equals 7.